still remember the Boyle and the Charles law? Now if you do, let's solve another gas law. This is the Gay-Lussac law. Have you tried having a long drive in summer? Driving too long during summer where the weather is too hot may cause the tire of your vehicle to burst or blow up. And that will be explained by the Gay-Lussac law. The person who is credited in the determination of the temperature-pressure relationship in gases at a constant volume is Joseph Louis Gay-Lussac. He deducted that the pressure of the gas is directly proportional to its temperature. It simply means that as temperature increases, pressure also increases and vice versa. When gas molecules are heated in a rigid container, which has a fixed volume, the molecules become more excited and tend to move faster. That makes the molecules collide more often with the wall of the container, thus rising with a high pressure. Therefore, high temperature leads to a high pressure. On the other hand, gas molecules which are exposed to low temperature move more slowly, with less frequent and weaker collisions with the wall of the rigid container, thus resulting to a low pressure. In conclusion, low temperature leads to a low pressure. That explains the direct relationship of pressure and temperature. Mathematically, the direct relationship between temperature and pressure at a constant volume is expressed through this equation. Thus, arising with the Gay-Lussac law formula, P1 over T1 is equal to P2 over T2, where P1 as the initial pressure, P2 as the final pressure, T1 as the initial temperature, and T2 as the final temperature. Let us now proceed to the application of Gay-Lussac's law formula in a given problem.
So we have the following given from the problem, which are 1.5 atm at 30 degrees Celsius. We also have 0 degrees Celsius. So what is asked in the problem is the resulting pressure. Therefore, we are looking for P2. And 0 degrees Celsius makes this P. Now, these two variables are the initial pressure and the initial temperature. Just like what we did with Charles' law, you have to convert this first into Kelvin, being the absolute unit for the temperature. Again, to convert this to Kelvin, we'll simply add 273. So the initial temperature will be 303 Kelvin, while the final temperature is 273 Kelvin. Looking back, with the Gay-Lussac law formula, in which P1 over T1 is equal to P2 over T2, we will derive again this formula since we are looking for P2. So again, to derive the formula, we'll have multiplication, cross multiplication. So we'll have P1 times T2 is equal to P2 times T1. Then divide both sides by P1, so the P1 will be cancelled and P2 will remain on one side. So our final formula will be P2 is equal to P1 times P2 over P1. The right formula that we have, in which P2 is equal to P1 times P2 over P1, we will simply substitute all the given from the problem. So your P1 is 1.5 pressure, which is 273 Kelvin, divided by the initial temperature, which is 303 Kelvin. So the final answer, after multiplying and dividing all the variables, is 1.35 atm. Expressing your final answer into significant figures, having 1.5 has two significant figures, therefore your answer must be expressed having two significant figures. Therefore, our final answer will be 1.4 atm.
There you have it! Now you've learned another gas law. See you again next time for the new episodes of Learning, to the program that gives you not only the basic but also the complex lesson in science. Again, I am your teacher AJ.
And I am your Nancy.
This is Super Science. Bye!